Let's now look at solving full geometric pattern questions. So we are given the pattern here 1, 2, 4, 8. I know that this is a geometric pattern because I'm multiplying by 2 each time. 1 times 2 will give me 2, 2 times 2 will give me 4, and 4 times 2 will give me 8, and so forth, which makes my ratio there positive 2 because I'm multiplying by 2. So the first question, write down the next 3 terms of the sequence. So that would be 8 times 2, which would give me 16. 16 times 2 would give me 32, and 32 times 2 would give me 64. Those are my next 3 terms of the sequence. Okay, the second question, find the nth term of the sequence. So again, to find the nth term or the general formula of a sequence, you need to start with the geometric formula, which is Tn is equal to a times r to the power of n minus 1. Remember, to find the nth term, all you do is you substitute the a value and the r value. So our a value was given as positive 1, so I'll substitute 1 into the formula. My r value we worked out to be positive 2 because we were multiplying by 2, and that meant that our ratio is 2. So don't calculate any further, that is your final answer there. The third question, what will the sixth term be? Now, we did a question like this before. What will the sixth term be? This means that n is equal to 6. So when we substitute into our formula, this is our general formula that we calculated previously. We'll substitute, instead of n, we will substitute 6. So there we go, there's our 6. Instead of n, we substitute 6. Okay, so we work this out. Tn is equal to 1 times 2 to the power of 6 minus 1. Now 6 minus 1 is 5. So that will become T6 is equal to 1 times 2 to the power of 5. Work with the brackets first. 2 to the power of 5 is 32. 1 times 32 will give me 32. So the sixth term in this pattern will be 32. Okay, the next question, will 64 be found in the sequence? Remember, when we approach a question like this, we need to realize that the value given needs to be in the place of Tn. So we start with our general formula that we have obtained for this problem, which is Tn is equal to 1 times 2 to the power of n minus 1. We are going to substitute 64 in the place of Tn, and we are going to solve for n. So we need to get rid of this 1 first. Because it's being multiplied by the 2 to the power n minus 1, we need to do the opposite of multiplication, which is division, as you can see here. So 64 divided by 1 will equal to 2 to the power of n minus 1. 64 divided by 1 is 64, so that is equal to 2 to the power of n minus 1. Now, we have a prime base on this side, which is 2. We also need to make the left-hand side a prime base as well, preferably with the prime base being 2. So I know that 2 to the power of 6 is equal to 64. So if 2 to the power of 6 is equal to 2 to the power of n minus 1, the next step I can do is cancel off my prime bases because they are. So if I cancel off my 2's, I will be left with 6 is equal to n minus 1, and this I can solve simply by putting my like terms together. So I take my constant over, that becomes 6 plus 1 is equal to n, so n will equal to 7. So I will conclude by saying that yes, 64 will be found in the sequence. It will be the 7th term in the sequence. Remember, for n to be found in the sequence, it must be a natural number. So it cannot be a fraction, cannot be a decimal, and it cannot be a negative number.